Hi students, in this video, let's discuss the different types of charts. Now this piece of information will help you read the information given in data interpretation questions in a very quick manner. Alright, let's get started. We will discuss bar charts, line charts and pie charts in this video. Alright, now under bar charts, we'll have two types. We have the simple bar graph and the cumulative or stacked bar graph. Alright. Now under line charts, we'll discuss four types. That's the scatter graph, the simple line graph, a stacked line graph or a band diagram, and the cumulative line graph. And under pie charts, we'll discuss two types. That's the simple pie chart and a donut chart. Alright, now let's get started with bar charts. We have the simple bar graph coming first. So let's take an example to understand how this looks. So over here, I have the simple bar graph. Alright, now what are the important things to note when you have a simple bar graph? You can see over here that there is a heading. It says salary per month. So that gives me the information what this bar graph actually talks about. Now over here you have an x-axis and you have the y-axis. So what is the information in the x-axis? You can see that it is years, right? So over here you have 2019, this is 2020 and this is 2021. So the information is grouped by year. Alright. Now in the y-axis, you can see you have US dollars. Alright. So what would this mean actually? And also note the legend over here. You have that blue denotes John, orange denotes Bob, and gray denotes Andy. So that is also a very important piece of information. Now if we were to read this bar graph, for example, over here you can see that in the year 2019, John had $4,000 as his salary per month, right? Now, this simple bar graph could also be given in the form of a table. How would that look? That would be like this, right? So comparing these two will help you get a good understanding of a bar graph. So over here you can see that for John in 2019, the average salary or the salary per month as is mentioned over here was $4,000, and in 2020 it's 5,000. Over here you can see this is 5,000, right? This is 4,000, and in the year 2021 that's 5,500. So that's this piece of information over here, this graph, right? This bar. So that is a simple bar graph. All right, now let's move on. Before we go to the second type, you could also draw the simple bar graph by plotting the values horizontally, right? So that's this one over here. It's again very similar to the one we saw before. The only difference is that the bars are drawn in this manner. That is, it's horizontal, right? Earlier we had them vertical. It was like this, right? All right. Now again, you can see there is a heading over here. That is, it's salary per month. And you can see that this axis over here talks about US dollars, right? You have a legend that gray is Andy, orange is Bob, and blue is John. And over here in this axis you have years, right? So again, that's the same piece of information. It's just portrayed in a horizontal manner. Now again, you could also think of it as a table, right? So it's the same information that's there in this table and in this simple bar graph. All right, now we have covered the first type of bar chart, which is the simple bar graph. Let's move on to the next one, which is a cumulative or stacked bar graph. All right, so the key word over here is cumulative or stacked. Let's understand what this means. Now, when it comes to cumulative or stacked bar graph, there are two types. The first one is on the basis of percentage, and the second one is on the basis of value. All right, so let's get started with the first one, which is on the basis of percentage. Now, to understand what we mean with cumulative or stacked, let's dive right in and see an example. All right, so over here I have a cumulative or stacked bar graph which is on the basis of percentage. Now over here you can see in the y-axis I have percentages up to 100%, right? Now let's take one of the years. Again, over here the same piece of information as we've seen before is there. You have a heading which gives you an idea of what the information covered over here is. So it mentions over here distribution of goals scored. All right, and in the x-axis you have years, right? This is 2019, this is 2020, and this is 2021. You have a legend that says blue indicates John, orange indicates Bob, and gray indicates Andy. All right, now moving on to this part where it's described as a cumulative or stacked bar graph. Let's take the year 2019 and look at the data over here to understand what it means. So in the year 2019, all right, you can see that John covered 10% of the goals, or John scored 10% of the goals. All right. Now, Bob scored the remaining over here, right? That's 10 plus 10, which is 20. So Bob has scored 20% of the goals, right? And Andy scored the remaining, which is this much over here. That's 70%, right? So you have 1, 2, 3, 4, 5, 6, 7. So that's why that is 70% of the goals. You can see that each of these three values are arranged one on top of each other, right? So over here you have 10%, right? And then on top of that you put 20%, right? That's why even though the score of Bob is 20% of the goals, over here, that is the y-axis where Bob's part ends is at 30%, right? So this 30 is actually this 10 plus 20. So that is what we call with a cumulative or stacked bar graph. What about John? That's over here 10 itself because there's nothing below him, right? But what about Andy? Andy, you can see over here that's 100%, right? That's because you have 70 plus 10 plus 20. So that's how you get to 100. 70 plus 20 plus 10. All right. So that's a cumulative stacked bar graph. Now, if you had this in the form of a table, it would look like this, right? So you can see in this table that John scored 1 goal, Bob scored 2 goals, and Andy scored 7 goals. The total number of goals scored in 2019 is 10, right? Now, John's score is 10%. That's why you have it over here at 10%. Now, Bob's score is 2 out of 10. That's 20. So 10 plus 20 gives you 30. So over here we have 30, right? And all of them together you get 100%. Now, let's also see one more interesting thing about cumulative or stacked bar graphs. In the year 2020, the total number of goals scored is 20, right? 4 plus 6 plus 10 is 20, right? Now in 2019 it was 10, and in 2020 it is 20 goals, right? Even though the number of goals in both these years is different, you can see that in the graph form, in the cumulative stacked bar graph, this bar and this bar both have the same height, right? Because both of them represent 100%, right? It's just that 100% in 2019 is 10 and 100% in 2020 is 20. All right. So over here, let's quickly see. John scored 4 goals in 2020. So 4 out of 20, that's 20%, right? So this is 20%. So you can see over here also you have 20. Now Bob scored 6 out of 20, right? So that's equal to 30%, right? So that's 30%. So that's why you do 20 plus 30 and you reach up to 50 over here, right? And then Andy scored 10 out of 20. That's another 50%. And when you add 20 plus 30 plus 50, you get to 100%. And that's the same case with the year 2021. All right. So we have covered percentage based cumulative stacked bar graph, right? Now let's move on and look at a value based cumulative or stacked bar graph. Now let's take an example to understand this. All right. So again, over here you have a heading, you have a legend, you have a x-axis and y-axis. All right. Now over here, let's quickly see the table form of this stacked bar graph. All right. So again, it's distribution of goals. All right. Now in the year 2020, let's take that as an example. You can see that John scored 10 goals, right? So, and then Bob scored 5 goals. So you have 10 over here and you mark 5 on top of the 10, right? So that's why over here you have 15, which is 10 plus 5. So again, you are stacking one on top of the other, but the difference between these two, that is the percentage based and value based, is that in the percentage based, you have seen that all the bars will have the same height, which is representing 100%. But in the case of value based, over here in 2020, the total number of goals is 20 plus 10 plus 5, which is 35, right? So over here you have 35. And in 2019, the total number of goals is 10 plus 15, which is 25 plus 5, which is 30, right? So the heights are not the same because it is value based. All right, so we have covered the most important types of bar charts. All right, so we have seen the simple bar chart and we have seen the cumulative or stacked bar graph, right? And we have seen two types over here, which is percentage based and value based. All right, now let's move on to line charts. We start with the first type, which is a scatter plot or a scatter graph. Let's take an example. All right, now over here you can see there is a heading. It says relation between tree trunk diameter and tree height. All right, now in the x-axis you have trunk diameter in centimeter, and in the y-axis you have height in centimeter. All right, and then you have a legend which says that blue represents tree 1, orange represents tree 2, and white represents tree 3. All right, now over here you have a scatter plot. Now to quickly understand and be able to read this, let me show you how this would have looked if the information was given in a table. All right, so this table and this scatter graph give the same information. All right, let's try to read it. Over here you have that tree trunk diameter 50 and tree 1 would have had a height of 600, right? So over here, if this is 50, let this be 50, then tree 1 is blue, right? So this is blue over here. So it means that this dot gives you two pieces of information, right? Let's see that over here. So I have tree 1 and its tree trunk diameter is 50 centimeter. In that case, its height would be 600 centimeter. So you can see that in a scatter plot, you're just connecting two pieces of information about something, right? Now, what would this point over here denote? It says that a tree of trunk diameter 60 centimeter has a height of 400 centimeter, right? So this is 60 comma 400, right? Similarly, this point over here represents 100 comma 700, and this point over here represents 150 comma 710, right? A tree trunk diameter of 150 centimeter and a height of 710. So that's the same information over here. If you just take tree 1, 50, 600, that's this one over here, 100, 700, that is this point over here. Then you have 150 and 710, which is this point over here. And then you have 60 comma 400, which is this point over here. So that's what we talk about as scatter graph or a scatter plot, right? So remember, you have a heading and you have something on the x-axis and something on the y-axis. All right, let's move on to the next type of line chart, which is a simple line graph. All right, let's take an example. So over here I have a simple line graph. Now again, I have a heading. This says that this is marks in percentage. All right, now on the y-axis you have the percentage, and on the x-axis you have three exams. This is mock exam 1, this is mock exam 2, and then you have the final exam. And then there is a legend that says blue is John, orange is Bob, and gray is Andy. All right, now let's try to analyze Bob, or let's take say John. So John, over here we have three data points for John, right? So this is the percentage marks obtained by John in the mock exam 1, which is 70%. This is the percentage obtained by John in the second mock exam, which is 80%. And this is the final exam percentage obtained by John, which is 90%. All right, so you just join these 3 points and you have a simple line graph. Now if it comes to Bob, again you have 3 points, right? You have this point, and this point, and then you join it together and you have a line graph. When it comes to Andy, again you have 3 points, right? So Andy scored 40% in the first exam, he scored 60% in the second exam, and he scored 70% in the final exam. So you have 3 points and then you join it and you have a simple line graph. All right, so let's move on to the third type of line chart, which is a stacked line graph or a band diagram. All right, so this is similar to the stacked bar graph. You draw one on top of the other in the case of a stacked bar graph, right? Let's see how it looks over here. We have an example over here. All right, now let's take the case of 2019. All right, now we have 3 dots over here. Now let's say that in the year 2019, John, which is blue, all right, orange is Bob, and gray is Andy, John scored 5 goals. All right, now over here you can see that orange in this point is at 15, right? Now if it is given in the question that this is a stacked line graph, then how do we interpret this point over here? This means that in the year 2019, Bob scored 15 minus 5, which is 10, right? He scored 10 goals, which is this distance over here, right? And when it comes to Andy, he scored 30 minus 15, which is this distance over here, right? Which is equal to 15. All right. So again, when you add these together, you will get to this point over here, which is 30. So 5 plus 10 plus 15 is equal to 30. So this is what we call a stacked line graph or a band diagram, right? So one on top of the other. That's what you need to remember. Remember, if you don't know what this type of a line chart is, then you may make the mistake of reading this as a 15, right? Saying that Bob scored 15 goals, but that is not true. Remember, Bob scored only 10 goals if it is given that this is a stacked line graph. All right. Now let's move on to the fourth type, which is a cumulative line graph. Now, in a cumulative line graph, the values are added to those of the previous data point, right? And let's also, after I show you an example, we'll try to understand the difference between this one over here, that is a cumulative line graph, and the stacked line graph. All right. Now over here, I have an example. All right. Now let's say that this is about two products. You have product 1, that's blue, and product 2, which is orange, right? And then you have cumulative sales across 5 months, and the y-axis is in dollars. All right. Now let's analyze product 1. And remember, it's given in the question that this is a cumulative line graph. That's the context. All right. Now, if that is given, let's try to understand the sales for each of the months. All right. So over here, I have 100, right? And in February also, this is at 100. And in March, this is at 200. All right. Now, how do we interpret this? Now, in Jan, the product sold $100. All right. In Feb, the product sold 100 minus 100, which is equal to $0, right? Because it's given that this is a cumulative line graph. So we add up, right? And in March, the product sold 200 minus 100, which is equal to $100. This is how you interpret a cumulative line graph. Now over here, you have 100. Now, if these pieces of information were given, let's try to plot it back into a cumulative line graph. So the first one is 100. So we plot this point over here. And then in February, if the sales is 0, the point which we plot for February is 100 plus 0, right? So that is equal to 100 itself. So we plot 100 over here. And for March, we plot 100, which is what we have till February, plus the sales in March, which is 100. So 100 plus 100, that's equal to 200. And that's this point over here. Similarly, this point over here will be 200, which is what we have over here, plus the sales in April, which is 150 in this case. So this is what we call a cumulative line graph. You can see that as we move forward, we take it in a cumulative manner. But in the case of a stacked line graph, it was one on top of the other, right? If we have product 1 sales as 100 and say product 2 sales also as 100, then if it was a stacked line graph, we would have marked product 2 over here, right? And then both the products are one on top of the other. But over here, it's for one product itself that we keep adding to the previous value and arrive at the next value. For example, over here we had 100 and we add 100 plus 0 to get 100 over here, and we add 100 plus 100 to get 200 over here, and over here we add 200 plus 150 to get 350 over here. All right, let's get back to our list of different types of charts. So we have covered 2 types of bar charts and we have covered 4 types of line charts so far. Now let's get to 2 types of pie charts. The first one in the pie chart section is the simple pie chart. All right. So a simple pie chart, let's try to understand that by an example. So over here you have a pie chart. Now you can see that it's just a circle and you divide it into different regions. Now in the legend, you can see that blue is product 1, right? And orange is product 2 and gray is product 3. So how do we read this? Over here, you can see that 30% of the sales in the last quarter came from product 1, right? Similarly, you can see that 50% of the sales came from product 2 and 20% of the sales came from product 3. So that's a simple pie chart. All right. Now let's also think of a few interesting things over here. If you have a simple pie chart, let's draw that over here. And let's say again, let me draw the same thing over here. You have product 1 over here, and you have product 2 over here, and you have product 3 over here. Now you can see that all of these together form 360-degree, right? So you can see more of this in the section where we cover geometry. If you take the degree measure around a point, you get 360 degrees. So this whole thing is 360 degree, right? Now 360 degree will represent 100% in a pie chart. So this is something important that you should know. So over here you have 360 degree, and that's 100%, which is all of this together. Now if you want to find out this angle over here, is just convenient to quickly mention that over here as well. So if you want to know this angle over here, you know that 100% is 360 degree. You just need to find out what degree is 30%. So that would be 360 divided by 100 into 30. All right. So that's approximately 108 degree. So this angle over here will be 108 degree. So this is also something interesting about pie charts. All right. Now let's move on to the second type of pie chart, which is a donut chart. All right. So it's very similar to the pie chart which we discussed already. The only thing is that you have two layers. All right. So over here you can see that you have two rings, right? Now it's mentioned that the outer ring indicates sales and the inner ring indicates profit. All right. Now you have the legend over here. Blue indicates product 1, orange is product 2, and gray is product 3. So if we were to convert this pie chart into a table, how would it look like? Let's do that over here. You have sales and you have profit. Now from product 1, you have 20% of the sales, right? Because this is 20% over here. From product 2, you have 60% of the sales, and from product 3, you have 20% of the sales. Now when it comes to profit, from product 1, you have 30% of the profits. You have 50% of the profits from product 2, and you have 20% of the profits from product 3. So in this way, we have covered the important types of bar charts, line charts, and pie charts. Now let's move on and do some interesting practice problems. Hi students, before we start practicing data interpretation questions, let's quickly discuss what strategy or what are the things to keep in mind when you attempt these type of questions. All right. Now in data interpretation questions, it's very important to understand the big picture. What is the chart talking about? All right. Do remember to check the headings, the units involved, and any axis labels. All right. And also do check whether the axis is increasing at a constant interval or in a manner that is not constant, right? You could have a diagram where this is 10 and then this is 100, right? This is 10, this is 100, and this is 1000, right? In this case, even though this distance looks the same, right? Because it's mentioned in the axis labels, so you have a case where it's not increasing in a uniform manner. All right. What are some other things to keep in mind? Always try to observe if there is any general trend in the data given. All right. Check for spikes. Are there spikes in data? Now, always make sure that you read the questions very carefully. Check the units especially. You may have one type of unit in the question and a different type of unit in the answer. For example, in the question, if the options are in kilograms and the answer is in grams. With question, I mean the given question stem. All right. Now you could also have a question stem where the data is provided in terms of weeks. All right. And the answers could be in terms of days. So all of this is possible. So take special care to note the units involved. Also do check the answer choices because they give you an idea about the degree of accuracy needed. For example, if the answer are in the form 10, 50, 100 and 200, you can see that they are quite far away, right? So even a lower degree of accuracy while solving will help you arrive at the correct answer. But if the answer choices are 11, 12, 13 and 14, then you need to have a higher degree of accuracy while calculating. All right. And also do remember to try to estimate and get to the answer, right? So you don't need to find the exact answer unless it's a box where you need to fill in the answer. So always try to estimate. And remember, graphs and charts are always drawn to scale. All right. So let's get started with the first question set. So this is the first question set. Refer the chart below for question 1, 2 and 3. All right. Now over here you have percent of girls and boys in a school by class. All right. And it's given that the total boys is 500 and total girls is 400. And over here in the x-axis you have percent. So this is 0%, this is 5%, etc. In the y-axis you have classes, class A, B, C up to J, and the labels say that orange is for female and blue is for male. So you have 3 questions over here. Pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Now let's do it together. The first question, it says what percent of the children in class D are female? So that's what we need to find out. Now over here we have class D, right? Now it's mentioned that in class D, this bar over here represents the percentage of females of the total number of girls, right? So this is over here, you can see this is 10, right? You have 10 over here. So this is 10 over here, and blue is for male or boys, right? So over here you have 16. So let's note that over here we have 10% and 16%. All right. Now 10% of 400. How much is that? That's equal to 40, right? And you have 16% of 500. So that's equal to 16 into 500 by 100, which is equal to 80. Now the question says what percent of the children in class D are female? So you just need to find out what percent of the total is 40. So that's 40 by 40 plus 80, which is equal to 40 by 120, which is equal to 1 by 3, or that's 33%. So the correct answer to this question is option A. Let's move on to the next question. In this school, class E is taught by 7 teachers. What is the ratio of number of children to the number of teachers for class E? All right. So it's not a difficult question, right? We just need to find out the number of children. All right. So over here we have class E. So this is class E, right? Now you can see that over here this is 8% and this is 9%, right? So let me note that over here you have 8% of the girls in class E and 9% of the boys in class E. So 8% of 400, how much is that? That's equal to 32, right? And 9% of 500, that's equal to 45. So how do you do this? 8% of 400 is nothing but 8 by 100 into 400, right? So you get 8 into 4, which is 32. Similarly, 9% of 500, let me show you one more way in which you can think about this. 1% of 500 would be 500 by 100, which is 5, right? So if 1% is 5, then 9% will be 9 into 5, which is 45. So you can think in either of these two ways when it comes to this calculation. So we have found that there are 32 girls and 45 boys. So the total will be 32 plus 45, which is equal to 77. All right. So we know that there are 77 children and it's given that you have 7 teachers. So the ratio of teachers to students, right? Or sorry, it's mentioned over here, students or children to teachers. That's 77 divided by 7, right? Because there are 77 children and 7 teachers. So 77 by 7 is the same as 11 by 1. And remember, 2 you always can denote 2 as divided. So 11 is to 1 is the same as 11 by 1. So the correct answer over here is option B. All right, let's move to the next question. That's the third question. Let me make some space over here. All right. Now the third question says, for class B and class I combined, 1 by 6 of the females and 1 by 12 of the males joined the adventure club. What fraction of the combined number of children in these two classes joined the adventure club? All right, so that's the question. Now over here you have class B and over here you have class I. So let's check the percentages. Over here this is 4% and this is 2%. Now let's note that and convert that into the actual number of kids. So 4% of 400. 1% of 400 will be 4. So 4% of 400 will be 16. So there are 16 girls in class B and you have 2% of males. So 1% of boys is 5. So 2% of boys is 2 into 5, which is 10. So there are 10 boys in class B. Alright. Now what about class I? You have 14 over here and you have 22 over here. So 14% of 400. How much is that? 1% is 4. So 14% is 14 into 4, which is 56. Right? Now over here you have 22% boys, right? 1% of boys is 5, right? Because 100% is 500. So 22% will be 22 into 5, which is equal to 110. So that's what you have over here. So in class I, you have 56 girls and 110 boys. Alright, now it's given that 1/6 of the females join the adventure club. So what's the total number of females? That's 16 plus 56. So 1/6 of 16 plus 56, that's equal to 12. So 12 girls joined the adventure club, and then you have 10 boys and 110 boys over here. So the total number of boys is 10 plus 110, which is 120, and it's given that 1/12 of the males joined. So 1/12 into 10 plus 110 is 1/12 into 120, which is equal to 10, right? So a total of 10 boys and 12 girls joined this club. So the total number of children that joined is 12 plus 10, which is equal to 22, right? And the total number of children in these two classes combined is 56 plus 110 plus 16 plus 10. That is equal to 192. Let me write that over here. In class B, you have 10 plus 16, right? And in class I, you have 56 plus 110. So this is the total. So when you add this up, you will get 192. Therefore, in this fraction over here, the numerator is 12 plus 10, which is 22. And the denominator is 192, which is what we got over here. Remember, this 22 is 10 plus 12. Alright, let's move on to the next set. Alright, let's do this question. Question 1, 2, 3 and 4. Refer the chart given below. Now, this chart talks about the value of imports to and exports from country A for the time period 2010 to 2019 in US dollars. Alright, now on the x-axis we have years, alright, and in the y-axis we have billions of dollars. Alright, so and then the legend says the blue line is for exports. Alright, so this is exports, and this one over here is for imports. Alright, now over here we have 4 questions. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now question 1 says, for which of the 7 years from 2011 to 2017 did exports exceed imports by more than $6 billion? Indicate all such answers. So this is a multi-select type of question. If there are 2 or 3 or 4 correct answers, we need to select all of them. Alright, now the gap between export and import has to be 6 billion, more than 6 billion, right? Now over here you can see that the trend is that exports is always greater than imports. Alright, so the gap between these two should be more than 6 billion. Now let's try one by one. Now remember, we don't need to check 2010 and 2018 and 2019 because the question only covers the period from 2011 to 2017. Alright, now what about 2011? Now over here you have exports at this point and imports at this point, right? Over here you can see that this gap is $2 billion. So over here you have 2, 4, 6, and it's more than 6, right? So yes, 2011 qualifies. What about 2012? Now over here this is 4, this is 2 plus 2, 4, and this is less than 2, right? So 2012 does not qualify. And similarly 2013 also does not qualify, right? This is 2, this is 2, and this is 2. So this is exactly 6 billion. But we need to find years in which the gap is more than 6 billion. 2013 also does not qualify. Alright, what about 2014? That's just a little bit more than 4, right? Somewhere close to 5 billion. So no. What about 2015? That's even less, right? So 2014 and 15 don't qualify. What about 2016? You have imports over here and exports over here. So this is 2, 4, 6, 8, and it's more than 8, right? So yes, 2016 qualifies. And what about 2017? That's 2, 4, and then this is probably not enough to cover this gap, right? If you take this much and put it over here, you'll just reach somewhere over here. So again, definitely it is less than 6 billion. So 2017 also does not qualify, and the correct answer is option A and option F. Let's go to the next question. The value of imports for 2016 was incorrect and should have been 11 billion. When this rectification is done, the average value of imports per year for the 10-year period would have increased by how much? Alright, so over here, the imports for 2016 is marked as 8 billion, but it should have been 10 billion. So if you do this change, that is you go from 8 to 11, that is imports increase by 3 billion. How much does the average change? Alright, so remember, average is sum by number of items, right? So over here you can see that the sum is increasing by 3 billion, right? And the number of items is 10 because you have 10 years over here. Therefore, the increase in the average is 3 by 10, which is equal to 300 million, right? This is 3 billion. So 0.3 billion or 300 million. Therefore, the correct answer to this question is option B. Remember, average is sum by number of items. And over here, whatever we had over here, initially we had a sum, right? Now, the true sum is S1 plus 3 by 10, right? Now, S1 by 10 is the initial average which we had, and we have to increase this by 3 by 10. That's what we have over here. That's how we get that the increase is 3 by 10 billion or 300 million. Alright, now let's go to the next question. Which of the following is closest to the average to the 9 changes in the value of exports between consecutive years from 2010 to 2019? Alright, now over here you can do this question in two ways. One is a time consuming way and the other is an easy way. So let's try to understand the concept being tested over here. Now let's take a simple example. Say we have a value that changes from 2 to 4 and then from 4 to 10. So from 2 to 4 there is a change of 2, and from 4 to 10 there is a change of 6. So the average of the changes is 2 plus 6 by 2, which is 8 by 2 or 4, right? Now this is one way in which you can do this question. Over here, instead of 2 changes, you will have 9 changes. So you can find each and every change, add them up and divide them by 9. Alright, so that's a time consuming process, right? Now another way is, if you consider the same example over here, if we change from 2 to 10, there is a change of 10 minus 2, which is 8, right? And then there are 2 changes. So you divide that 8 by 2, and that also is equal to 4. So this is the faster way, right? So over here, we have how many changes? We have 9 changes starting from 2010 going up to 2019, right? So what is the value at 2010? Over here you have 7 billion, right? So this is 7 billion and the last value is approximately 12 billion. All right. So the difference is 12 minus 7, right? Which is equal to 5. So we have 12 minus 7 is equal to 5 and we have 9 changes, right? So 2010 to 11 is one change, 11 to 12 is the second one. Similarly, this is the third, fourth, fifth, sixth, 7, 8 and 9 changes. So this 5 billion change is happening over 9 changes. Therefore, the average is 5 by 9, which is very close to 555 million, right? 5 by 10 would have given you 500 million. 5 by 9 has to be greater than 500 million, right? But not very much greater. So the correct answer to this question is 555 million, which is option A. You can also take out your calculator and find out 5 by 9 and you will get the answer as option A. Let's move to the next question. In 2013, the value of exports was approximately what percentage greater than the value of imports? So we are talking about 2013, all right? Now, the value of exports is 14 billion and the value of imports is 8 billion. So the difference is 14 minus 8, right? So that's equal to 6. And over here, we need to find out the change was approximately what percentage greater than the value of imports, than the imports. Therefore, we have already seen percentage change, right? In this case, the denominator is the imports and imports is 8. Why is the denominator imports? Because it's mentioned that by what percentage greater than the imports, right? So imports is in the denominator, and the correct answer to this question is 14 minus 8 by 8, right? So that gives you 6 by 8 or 3 by 4, right, which is equal to 75%, and that is answer option C. Let's move to the next set. Let's do this question. We have questions 1 to 4 and we have to refer the charts given below. Now over here we have a simple bar graph, right? And it gives number of vehicles of different types in millions. All right. So we have cars, bikes, moped and bicycles, and the blue bars are for 2010 and the orange bars are for 2030. All right. Now over here we have a stacked bar graph and it is in percentages, right? And it talks about the maintenance cost per year in 2010. And over here we have bicycles and we have the other three. All right. So bicycles is one category over here and these three together is clubbed together. All right. So we have 4 questions over here. Pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Now let's do this together. The first question says the median maintenance cost for a bicycle in 2010 was in the range. All right. So maintenance cost is given over here, right? And we need to find the median maintenance cost. Now remember, if you have a set of data arranged in either the ascending or descending order, the median is the middle value, right? So over here we have it in percentages. So the median will be something which is at 50% range, right? And over here at 50% we have the range $151 to $199, right? Therefore the correct answer to this question is option C. All right, let's get to the next question. Now if it is projected that the given 4 vehicles comprise 1/4 of all the vehicles in 2030, then approximately how many million vehicles will be there in 2030? All right, now over here the number of vehicles is given in this simple bar graph. So let's check in 2030 what are the vehicles of the 4 categories. All right, so over here we have something that is about 25, right? This is 25 and this is 30. So how much is this? This one over here would be 28, right? So let's write that over here. Similarly over here you will have 27, right? This is 25, 26, 27. So you have 27 over here. Over here you have 20. It's exactly over here. That's 20. And over here you have 10 at this line. So it's 1 below that. So you have 9. So all of these values are in millions. All right. So the total number of vehicles of the 4 given categories is 28 plus 27 plus 20 plus 9 million, right? So when you add these 4, you get 84 million. Now it's given that the sum of these 4, that is 84 million, is 1/4 of all the vehicles, right? So if X is the total number of vehicles, then 84 is equal to X by 4, right? So therefore X is equal to 84 into 4, which is equal to 336. So the correct answer is there are 336 million vehicles in 2030. All right, let's move to the next question. In 2010, approximately how many more bicycles had maintenance cost less than $100 than had maintenance cost $301 or more in millions? All right, so over here we need to check the maintenance cost, right? So that's this question about. So over here maintenance cost is given in this stacked bar graph. Now we need it for bicycles, so that's this one over here, and we need to check the 2 categories less than 100 and $301 and above. All right, so this is something more than 20%, right? So let me take this as 24% over here, right? Because it's a little bit below the mid value. And over here this is just a little bit above 10%, because this much is 10. You can see that the green part is coming beyond it. It's approximately till here. So let me take this as 11%, right? So we just need to find the difference between these two, and we know that in 2010 the total number of bicycles is given by this blue graph over here, right? This blue bar. So that is at a value of 10 million, or how much is this? No, 8 million. So this is at a value of 8 million, right? So we just need to find out 24% of 8 million minus 11% of 8 million, right? So difference of these two percentages is 24% minus 11. That's equal to 13%, right? Let me make some space over here. So all we need to find out is 13% of 8 million, right? Which is equal to 1.04 million, right? 10% of 8 million will be 0.8 million, right? So it's a little bit above that. Now over here, why did we do it like this? Let me quickly show it to you over here. Let me take some space. Now if I do 24% of 8 million minus 11% of 8 million, right? I have 8 million in both these numbers, so I can take it out. I can club it together and I can say I just need to find out 24% minus 11% of 8 million. So that's what we have done over here, right? 24 minus 11 is 13%. 13% of 8 million is equal to 13 by 100 into 8, which is 1.04. So the correct answer to this question is option B. Now you can also see it like this. Say you take this as 20%, all right? So it's very close to 20, right? So just to make the calculation easier, so we have 20% over here, and this is a little bit above 10%. So let's take it as 10%. Even if you take it as 20 and 10%, the difference is 10%, and 10% of 8 is 0.8, right? So again, this 2.04 and 2.1, these are way above, right? So they are directly eliminated, and 0.4 is way below, right? So you're just left with option B. So again, the correct answer is 1.04 million. All right, now let's go to the last question. It says, among the 4 vehicle categories, for the one which is projected to have the largest percentage increase from 2010 to 2030, approximately what is the percentage increase? All right, so I hope you have given this a try already. Let's do it together. I'm just making some space over here. Remember, what is percentage increase? If you have a value, say 8, that's increasing to say 15. What is the percentage increase? It's the difference by the initial value, right? The difference over here is 7, right? Because 15 minus 8 is 7 and the initial value is 8. So the percentage increase when you grow from 8 to 15 is 7 by 8 into 100, right? So we have already covered that in the section on percentage increase. So let's proceed at this moment doing this question. So over here we have how many categories? We need to check the categories where there is an increase from 2010 to 2030. Is there any one where there is a decrease when you go from 2010 to 2030? No, you haven't. Yes, over here, right? You can see that 2010 it's more and 2030 you are having a decrease. So it's definitely not cars, right? It's directly eliminated. So we are just left with 3 more where there is an increase. All right. So over here there is an absolute increase of 2, right? It's going from 25 to 27. So we have an increase of 2 over here. What about this mopeds? Over here also you have an increase of 2, right? It's going from 18 to 20. What about this category of bicycles? There is an absolute increase of 1 million. All right. Now what is the percentage increase when it comes to bikes? It's the absolute increase divided by the initial value, right? Which in this case is equal to 25. So we have 2 by 25 over here. What about mopeds? We have 2 by 18, right? Because this value over here is 18. So we have 2 by 18 over here. And in this case, we have 1 by 8. So let me write the 3 fractions over here. We have 2 by 25, 2 by 18 and 1 by 8. Now among these 3, which is the greatest one? It's 1 by 8, right? So how do you do that? Let's quickly check that. Let me make some space over here. Now if I want to compare 2 by 25 and say 1 by 8, which among these two is greater, 2 by 25 or 1 by 8? What do? I cross multiply, right? So in this case 2 into 8 is 16 and 25 into 1 is 25. So which among 16 and 25 is the bigger value? It's 25, right? So because 25 is greater than 16, you put a sign like this, and the same sign holds true for these two fractions. That is 1 by 8 is greater than 2 by 25. All right. So it's definitely not this one because we need to find the greatest, right? And we have just found that 1 by 8 is greater than 2 by 25. Now let's compare these two. We have 2 by 18 and 1 by 8. Again, you cross multiply. 2 into 8 is 16 and 18 into 1 is 18, right? Again, 18 is greater than 16. So the same sign holds true over here as well. So 1 by 8 is greater than 2 by 18. Therefore, again 2 by 18 is also eliminated and the correct answer is 1 by 8, and 1 by 8 is nothing but 12.5 percentage. To find this, you can either divide 1 by 8 and multiply it with 100, so you'll get 12.5, or we have already covered this in the fraction to percentage conversion table. Alright, let's move to the next question set. Let's do this question. Refer the chart given below. So we have 5 questions. Now this chart over here talks about the median sale price in thousands of dollars. Alright, so that's the unit over here, right? It's thousands of dollars. Now this chart over here talks about villas and apartments sold in the US from 1990 to 2002 in millions. So it talks about the number of villas and apartments sold. Alright, now over here the blue bars talk about villas and the orange bars talk about apartments. What about the line, this one over here? This is the blue line which talks about the number of villas that were sold, and this orange line talks about the number of apartments that were sold. Alright, now over here we have 5 questions. Pause the video, give it a try, make sure that you attempt all the 5 questions before you go ahead with this video and we solve it together. Alright, we are back. I hope you have given it a try. Now let's do it together. The first question reads, which of the following could be the actual number of villas sold in 1998? So this is the chart that talks about the number of villas sold. Now the year is 1998, which is this one over here. So what's the number of villas sold? It's this point over here, right? So that's something between 4 and 5, right? And the unit over here is millions. So definitely the number of villas sold in 1998 is a value which is between 4 and 5 million, right? Therefore, clearly we can eliminate option C, D and E, right? Because option C is not between 4 and 5. It's something greater than 3 million. Similarly, option D is 2 million something, right? And option E is 6 million something. So these 3 values are not between 4 million and 5 million. So we eliminate these 3. Now we are left with 2 more, right? So this option over here also has to be eliminated because it's just a 5-digit number, right? So it's even less than 1 million. It's just 5 digits. So this is also not the correct answer, and hence we are just left with one option. Therefore the correct answer is option A. Alright, let's go to the next question. It reads, for which year was there an increase over the previous year in the number of villas sold? So when it comes to villas sold, the graph should be something like this, right? Because there is an increase, but a decrease in the number of apartments sold. So when you talk about apartments, it should go like this. So that's what we are asked. In which year is there a shape like this, right? So what do you need? Actually, it's talking about was there an increase over the previous year. So this is the current year, all right? This is the current year. So there was an increase in the number of villas over the previous year and a decrease in the number of apartments sold compared to the previous year. All right. So we just need to find out where there is a shape like this in this graph. All right. Now we are given 5 options. What about 1990? No, we are having the reverse, right? So 1990 is definitely not the answer. What about 1992? 1992, I have something going down over here and something going up over here. So again, that is also not the correct answer, right? It doesn't look like this. So this is also not the correct answer. What about 1994? You can see, yes, we are having the shape that we want. Therefore, the correct answer to this question is 1994. You can see that there is an increase in the number of villas sold and a decrease in the number of apartments sold. And that is what is asked in the question. All right, let's get to the next question. It reads, from 1990 to 2001, the percent increase in the median price of villas sold was closest to. So we are going from 1990 to 2001, right? All right, so let's try to do that. What's the median sale price in thousands of dollars for villas in 1990? That's this value over here, right? That's very close to 25. I can say it's midway between 20 and 30, right? This is $25,000 and this value over here is very close to $65,000. So let me write that over here. I have 25 over here and 65 over here. So I just need to find the percentage increase when I go from 25 to 65, right? So that is a straightforward calculation. You just need to find out the difference between these two divided by the initial value, right? That's how you find the percentage change, right? So 65 minus 25, that's equal to 40, right? So the change is 40 and the initial value is 25. Therefore, the correct answer to this question is 40 divided by 25, right? Now, if you take out 8, if you take out 5 from the numerator and denominator, you are left with 8 by 5, right? And that is 160 percentage. Why is that so? You just need to divide 8 by 5, right? 8 by 5, it goes once and you're left with 3 and 1 3 by 5. And 3 by 5 is nothing but 60 percentage and 1 is 100%. So 100 plus 60 gives you 160 percentage. Or you can just divide 8 by 5 and you'll get the answer as 1.6, which is equal to 160%. Alright, now let's move on to the next question. In the year in which the median price of villas sold was closest to the median price of apartments sold, approximately how many million villas were sold? So you first need to find the year, right, in which the median sale price of villas and apartments is very close to each other, the closest among the 5 given years, and then you need to find the number of villas sold in that year. Alright, so which is the year over here? You just need to check based on observation in which of these 5 is the gap between the blue graph and the orange graph the least, right? So it's definitely not this one, right? There's a big gap over here. If you compare this one and this one, this has a bigger gap, so this is not the one. If you compare these two, again this has a bigger gap, so it's not this one. And if you compare this one and this one, there is a bigger gap over here, so it's not this one. So you're just left with 1990. So you just need to find out the number of villas sold in 1990, right? So villas is the blue line, so that's this one over here. So it's very close to 5, right? Therefore, the correct answer is option E. That's 5 million. Alright, let's do the next question. In the year 2000, the number of villas sold was approximately how many times the number of apartments sold? Alright, so this is the year 2000. We have the number of villas sold over here, right, which is very close to 3.6, right? That's 3 and this is 4, so it's very close to 3.6. If you count 1, 2 and 3, you have 3 lines over here, and this space between 3 and 4 is divided into 5 equal parts. So you're taking 3 out of that, that is 0.6. So 3 plus 0.6 gives you 3.6 over here, and this is at 5, right? So we have 3.6 and 5. So you just need to find out 3.6 is how many times 5. Remember, don't do the opposite, right? It's not asking how many times is 5, 3.6 times what, right? It's asking us 3.6 is equal to 5 into what. So we just need to find out x over here, which is equal to 3.6 by 5. Now, if you divide 3.6 by 5, that will be 0.7 something, right? So either you just divide it, or you can notice that 3.6 is very close to 3.5 and 3.5 is 0.7 times 5, because 7 into 5 is 3.5. So over here, when you do this calculation, you will get the answer as option B, which is 0.72. Alright, so the correct answer to this question is option B. Let's move on to the next set. Let's do this question. We are given a simple bar chart over here, and it reads number of 29 states by revenue category as per figures of the year 2002. And over here in this table, we are given the 8 revenue categories. Alright, pause the video, give it a try, and then let's discuss these 4 questions together. Alright, we are back. I hope you have given it a try. Let's discuss these questions together. Now, the first question reads, the median revenue of the 29 states revenue was in which GDP category? Remember, if you need to find the median, arrange the given values in either the increasing or decreasing order and find the middle value, right? Especially over here, because we just have 29 states and this is an odd number. Therefore, you just need to find out in which category will the 15th state be if you arrange all the 29 states in the increasing order of revenue, right? Remember, why is it the 15th one? Because you have 29 states over here. So the 15th state would be the middle value, right? If you had 3 states, then the second one is the middle value, right? If you had 5 states, then the third one would be the middle value. Similarly, over here, because you have 29 states, the 15th state is the middle value. All right. Now, if you had an even number of states, then you would have to take the average of the 2 middle value states to find the median, right? All right, but that's not the case over here. So let's proceed. So you can see that in category S1 you have 9 states, right? That's because this is between 8 and 9, so that's over here. So you have 9 states in category S1, you have 4 states in category S2, 5 states in category S3, and so on and so forth, right? All right, so if you were to arrange all the states in increasing order of their revenue, then the first 9 states would be of category S1, right? Because you have 9 over here. This is the least category. So you will have 9 data points over here in category S1. The remaining 4 would be of category S2. So 9 plus 3, 9 plus 4, that gives you 13. Again, the next one, the 14th, 15th, 16th, 17th and 18th state would be of category S3, right? Therefore, you can see that the 15th state is in the category S3, and hence the correct answer to this question is option C, that is S3. All right, now over here we have 4 more states, so let's mark them over here, 5 more. Okay, so S4 has 3, okay, and S5 has 2, S6 has 3, S7 has 2, and S8 has 1 state. All right, so let's proceed to the next question. Let me make some space over here. The next question reads, the number of states in GDP category S4 and S5 was approximately what percent greater or lower than the number in the category S6, S7 and S8. So in S4 you have 3 and in S5 you have 2. So 3 plus 2, that's 5 over here, right? And in S6 you have 3, S7 you have 2 and S8 you have 1. So 3 plus 2 plus 1, that's equal to 6. All right. So you just need to find the percentage increase or decrease when you go from 6 to 5. Remember, it is not from 5 to 6. As per the question, you're going from 6 to 5. Why is that so? Because it says the number of states in S4 and S5 was what percent greater or lower than the number of states in S6, 7 and 8. So whatever comes after than is where you're starting from. You're starting from 6 and you need to go to 5. So the percentage decrease in this case is the change divided by the initial value, and the change is 1, right? 6 minus 1 gives you 5 and the initial value is 6. So you just need to convert 1 by 6 into a percentage, and 1 by 6 is nothing but 16 percentage. You can either divide it or you can use the fraction to percentage conversion table which we have in the section where we discuss percentages. All right, let's get to the next question. The revenue of state XYZ in 2002 was 3.4 million. If the ratio of the revenue of state ABC to that of state XYZ was 5:3, in which revenue category was state ABC? Alright, let's convert this information given over here into an equation. Let A be the revenue of state ABC. Then, as per this information in the question, if you divide A by 3.4, which is the revenue of state XYZ, you will get 5 by 3, right? So that's given in the question. So all you need to find is A. Let's calculate the value of A. That would be 5 into 3.4 divided by 3, right? So this value over here will be approximately 5/2 by 3, right? So that comes in the category S6, and hence the correct answer to this question is option D. All right, now let's go to the fourth question. How many of the 29 states were in the 3 revenue categories S2, S3 and S4? So over here you have S2, that's 4, and S3, that's 5, and S4, that is 3. So 4 plus 5 plus 3, that's equal to 12, and hence the correct answer to this question is option B. Let's move on to set 6. All right, so over here we have the question. We have 4 questions and we have to refer the chart and the table given. Now the chart has a heading revenue from sale of chocolates in billions of dollars. All right, so this talks about revenue. All right, and the table talks about the number of chocolates sold. So it gives us a number. All right, now the table is for the year 2002 and the chart has years 2000, 2001, 2002 and 2003. All right, so over here you have 4 questions. Pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Now let's do it together. The first question reads, in 2002, the average, that is the arithmetic mean price per chocolate sold was $0.8. All right, For which of the following months in 2002 was the number of chocolates sold greater than 1/4 of the total number of chocolates sold in the last 2 months of 2002? Indicate all such months. So this is a question where you can answer or check more than one of the options. Alright, now remember the chart over here talks about revenue in billions of dollars, and the table over here gives us the number of chocolates sold in the year 2002. Alright, now we know that in the year 2002, which is the year of the question, $4 billion were made from the sale of chocolates, right? So this bar over here is at 4 billion. Alright, now it's given that the average price per chocolate was $0.8. Remember, average is the total divided by the number of chocolates, right? So in this case, the average, which is 0.8, is equal to the total, which is 4 billion divided by the number of chocolates, right? Therefore, I can say that the number of chocolates is nothing but 4 divided by 0.8, right? In billions, because this is 4 billion, right? So 4 divided by 0.8 is nothing but 5. So that means in the year 2002, 5 billion chocolates were sold, right? So that's 5 billion. All right. Now let me make some space over here. Now, what is the data given in the table? It talks about the number of chocolates sold in the year 2002, and the total over here is 3.585 billion, right? And you can see that data is only given up to October. Now in the year 2002, you have 2 more months, that is November and December. Therefore, the number of chocolates sold in November and December together has to be the difference between 5 and 3.585, right? So 5 minus 3.585 is equal to 1.415 billion. All right. So in the last 2 months together, that is November, December together, 1.415 billion chocolates were sold. All right. Now in the question, it talks about for which of the following months in 2002 was the number of chocolates sold greater than 1/4 of the total number of chocolates sold in the last 2 months of 2002. So we need to find out 1/4 of this value over here. That's equal to 1.415 by 4, which is equal to 0.353 billion, right? This is again billion, and that is nothing but 353 million. You convert it into million. So you just need to find out for which of the following months given over here, or look at the options. You don't need to check Jan and Feb because you only have March, April, May, June, July, August, September and October in the options, right? So in which of the months is the number of chocolates sold greater than 353 million? And you have the number directly over here. So you can see that the correct answer is April and June, right? In April you have 360 million and in June you have 375 million. In the other months given over here, you have less than 353 million. All right. Now let's proceed to question number 2. Approximately what was the percent increase in the annual revenue from chocolate sales from 2000 to 2002? All right. So in the year 2000, what was the revenue from the sale of chocolates? That's 3.5 billion over here, right? So you just need to find out the percentage increase from 3.5 to 4. Remember, percentage increase is nothing but the change by the initial value, right? So over here the change is from 3.5 to 4, that is a change of 0.5. Therefore the correct answer to this question will be 0.5 divided by 3.5, because 3.5 is the initial value, right? You're going from 2000 to 2002, so this is the initial value. Therefore this is nothing but 1 by 7, and 1 by 7 is approximately 14%, right? 1 by 7 is 14.28%, which is approximately 14%, and hence the correct answer is option A. All right, let's get to the next question. In 2002, the number of chocolates sold in June was approximately how many times the number of chocolates sold in October? All right, so you can see that in June you have 375 million chocolates sold, and in October it is 75 million. So you just need to find out 375 divided by 75, right? And that is equal to 5. Therefore the correct answer to question number 3 is option A. All right, now let me make some space over here and we go to the last question over here. 35% of the number of chocolates sold in March 2002 were chocolates made by company A. Alright, if they priced their chocolates between $0.5 and $1.5, which of the following indicates all possible values of the revenue are in $1,000,000 which company A made in the month of March? Alright, so over here, what is 35% of the number of chocolates sold in March? You can see from this table that in March, 300 million chocolates were sold, right? So you need to find out 35% of 300. That's equal to 105 million, right? How do you do this? This is nothing but 35 by 100 into 300. So if you do that, that's 35 into 3, which is 105. So company A sold 105 million chocolates in March. Now, the price is between $0.5 and $1.5, right? Now, if all the chocolates were sold at $0.5, the amount of revenue that they made would be 105 into 0.5, which is equal to 52.5, right? So if all the chocolates were sold at 1.5, that would be 105 into 1.5 and you get 157.5. So the revenue has to be in between these two values, right? Therefore, the correct answer to this question is option B. Let's move on to set 7. All right. So we have a pie chart over here and we have 4 questions. All right. Now the information over here says the values indicated are degrees. That means over here, this means 40 degrees. All right. This is 150 degrees. This is 70 degrees and this is 100 degrees. All right. So we have 4 questions over here. Give it a try. Pause the video and then let's do it together. All right. We are back. I hope you have given it a try. Let's do it together. Now, the first question says the contribution from information technology was what percent greater than the contribution from manufacturing? All right. So over here, before we answer this question, let me quickly revise what it means when you talk about degrees over here, right? Remember, the pie chart is a circle, right? So 100% of the revenue in this case would be represented by 360 degrees. So for example, over here for information technology, you can see that you have 150 degrees and for manufacturing, you can see that you have 70 degrees. So you could actually convert this degrees into percentage also. All right. So let me quickly show that to you over here. And remember, you don't need it for this question, but this is just for your understanding. So over here, you have 150 degrees, right? For information and technology. So how much percentage would that be? You just need to convert it from degrees to percentage. So 1 degree would be 100 divided by 360 percentages, right? That's 1 degree by dividing both these sides by 360. So to find 150 degree, you just need to multiply it. So that's 100 by 360 into 150. So if you calculate this, you are converting 150 degrees in terms of percentages. All right. So let me make some space over here. Now let's answer this question. Now remember, we are trying to do this question in the best possible manner, right? Because this is a time-based question. So over here, we need to find out the contribution from IT or information technology was what percentage greater than the contribution from manufacturing. So one way of doing it would be you could convert this 150 and 70 into percentage and then find the percentage change when you're going from manufacturing to information technology. But you don't need to do that. You can just keep it in degrees itself and solve the question. So let me show that to you over here. So we are basically going from 70 degrees to 150 degrees, right? And we just need to find the percentage change. So we know that percentage change is nothing but change by initial value. And if you do 150 minus 70, that is 80. So over here, the change is 80 and the initial value is 70. So you just need to find out 80 by 70 and that is nothing but 114%, right? 80 by 70 is 110 by 70 and 110 by 70 is 1 by 7. 1 by 7 is 14% as per the percentage to fraction conversion table. So this is nothing but 100 plus 14, which is 114%. Or you can do 80 by 70 in your calculator and you will get the same answer. So the correct answer to this question is option D. All right. Now let's proceed over here. Quick side note. Why don't you need to convert this into percentage? Let's quickly see. If you were to convert 70 into percentage, let's quickly write that over here. Remember 360 degree is 100%, right? So 70 degrees would be 100 divided by 360 into 70%. Similarly, 150 degrees would be 100 divided by 360 into 150. So if you want to find out the percentage change from this to this, that is in terms of percentage, what would it be? Again, the difference, if you subtract these two, the difference would be 80 into 100 by 360, right? And you're starting from here, so your denominator is 100 by 360 into 70. Over here also you can see that this factor and this factor cancel out, and you are left with the same thing that we got over here. So it's much faster if you don't change it. You can keep it as such and find the answer. All right, so let's proceed. So let me make some space over here and we go to the next question. The second question reads, how many of the sectors contributed more than the average contribution of a sector? All right, again, you could do this by converting it into percentages, but you don't need to do that, right? You can keep it in degrees as it is. Remember, the whole thing is 360 degrees, right? The whole thing is 360 degrees and you have 4 sectors, 1, 2, 3, 4, right? So the average is the total by the number of items, right? So 360 by 4 is 90 degrees, right? So you just need to check out how many among these 4 have a contribution that is a degree greater than 90 degree, because you need more than the average. So how many of these have greater than 90 degree? You can see that patents has 100 degrees, so that's greater than 90, and information and technology has 150 degrees, which is greater than 90. So the correct answer is option B, that is 2 sectors. All right, let's proceed to the third question. If the contribution from agriculture was $10 billion, find the contribution from patents and IPRs. All right, now over here you can see that agriculture is 40 degrees, right? All right, so 40 degrees is 10 billion, right? That's what's given over here, and you need to find out the contribution from patents and IPRs. So patents and IPRs is 100 degrees. So this is nothing but a direct application of the unitary method, which we always do. Like if you go to a shop and you say that 5 mangoes cost 100 rupees, how much does 10 mangoes cost? It's the same thing that we are applying over here. So 40 degrees is 10 billion. How much is 100 degrees, right? Because patents and IPRs are 100 degrees. So for this, you do 10 by 40 into 100, and that gives you 25 billion as the answer, which is option E. All right, now let's proceed to the last question over here. If the total revenue of the country ABC is 90 billion, find the difference of the contribution of IPRs and manufacturing. Again, over here, what is the contribution from IPRs? That's denoted as 100 degrees over here, and for manufacturing it is 70 degrees. Now we are doing this question in the fastest possible manner. One way is you could find out the contribution of IPRs individually, because 360 degree is 90, right? 90 billion over here, and you can find the contribution of 100 degree. So that would be the contribution of IPR. Similarly, you can do it for 70 degree. That would be the contribution from manufacturing, and then you can find the difference. But the faster method is over here, this is 100 degrees and this is 70 degrees. So what is the difference in degrees itself? That would be 100 minus 70, which is 30 degrees, right? So over here, we know that 360 degrees is 90 billion, and you just need to find out how much is 30 degrees. And we use the same method that we used over here. So for 30 degrees, I would do 90 by 360 into 30. All right. And that gives me the answer as option B, which is 7.5 billion. Let's move to the next set, which is set 8. All right, we have a pie chart over here, and it is mentioned that the values are indicated as percentages. All right, now it says that this is percent of users in Asia using different browsers. So you have Firefox over here, which is 32% of the users. You have Chrome, which is 40% of the users. You have Opera, which is 3% of the users. You have Safari, which is 10% of the users, and you have Explorer, which is 15% of the users. All right, now pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now the first question reads, find the number of users in Asia using Chrome. All right, in millions. Now the correct answer to this question is option E, that is, you cannot determine it, right? Because over here only percentage is given, right? No absolute value is given in the question. So in the question it's asked find the number of users, which is the absolute number of users in Asia, and you cannot find that out just using percentages, right? Therefore the correct answer to this question is option E. All right, let's move to the next question. Which among the following accounts for more than 50% of the Asian users? All right, let's go option by option. Option A has Chrome and Opera. So Chrome is 40 and Opera is 3. So 40 plus 3, that gives you only 43%. So that's not the correct answer. What about option B and C? Option B is Explorer and Firefox. All right, so Explorer and Firefox, that's 32 plus 15, right? So again, that's just 47. This is just 47. And Chrome and Safari is 40 plus 10, which is 50. So both of these are out. Remember, this is also out because in the question it's mentioned more than 50%. All right, let's move to option D. That's Chrome and Explorer. So if you do Chrome and Explorer, that's 40 plus 15, which is equal to 55. And hence that is the correct answer. All right, now let's move to the last question. If the total number of users using browsers in Asia is 1500 million, find the difference between the number of users using Explorer and Firefox. So Explorer accounts for 15% of the users and Firefox accounts for 32% of the users. Again, you can do it in two ways. You could find initially 15% of 1500, then you can find 32% of 1500, and then you can find the difference. But the faster way is just find the difference between these two percentages. That's 32 minus 15, which is 17%. And then you just need to find out 17% of 1500 million. So that is 17 by 100 into 1500. That gives you the answer as 255 million, which is answer option C.